A semantic network, or frame network, is a network which represents semantic relations between concepts. This is often used as a form of knowledge representation. It is a directed or undirected graph consisting of vertices, which represent concepts, and edges. History. In 1909, Charles S. Peirce proposed a graphical notation of nodes and edges called existential graphs that he called the logic of the future. This began the debate between advocates of logic and advocates of semantic networks. This debate obscured the fact that semantics networks, at least those with well-defined semantics, are a form of logic. Semantic nets were first invented for computers by Richard H. Richens of the Cambridge Language Research Unit in 1956 as an interlingua for machine translation of natural languages. They were developed by Robert F. Simmons and M. Ross Quillian at System Development Corporation in the early 1960s. It later featured prominently in the work of Alan M. Collins and Quillian. Basics of semantic networks. A semantic network is used when one has knowledge that is best understood as a set of concepts that are related to one another. Most semantic networks are cognitively based. They also consist of arcs and nodes which can be organized into a taxonomic hierarchy. Semantic networks contributed ideas of spreading, activation, inheritance, and nodes as proto-objects. Examples. Semantic net in Lisp using an association list. You would use the association function with a key of canary to extract all the information about the canary type. WordNet. An example of a semantic network is WordNet, a lexical database of English. It groups English words into sets of synonyms called synsets, provides short, general definitions, and records the various semantic relations between these synonym sets. Some of the most common semantic relations defined are meronymy, holonymy, hyponymy, hyponymy, synonymy, and antonymy. WordNet properties have been studied from a network theory perspective and compared to other semantic networks created from Roget's thesaurus and word association tasks. From this perspective, the three of them are a small world structure. Other examples. It is also possible to represent logical descriptions using semantic networks such as the existential graphs of Charles Sanders Peirce, or the related conceptual graphs of John F. Sower. These have expressive power equal to or exceeding standard first-order predicate logic, unlike WordNet or other lexical or browsing networks. Semantic networks using these representations can be used for reliable automated logical deduction. Some automated reasoners exploit the graph-theoretic features of the networks during processing. Other examples of semantic networks are Gelish models. Gelish English with its Gelish English dictionary is a formal language that is defined as a network of relations between concepts and names of concepts. Gelish English is a formal subset of Natural English, just as Gelish Dutch is a formal subset of Dutch, whereas multiple languages share the same concepts. Other Gelish networks consist of knowledge models and information models that are expressed in the Gelish language. A Gelish network is a network of relations between things. Each relation in the network is an expression of a fact that is classified by a relation type. Each relation type itself is a concept that is defined in the Gelish language dictionary. Each related thing is either a concept or an individual thing that is classified by a concept. The definitions of concepts are created in the form of definition models that together form a Gelish dictionary. A Gelish network can be documented in a Gelish database and is computer interpretable. Another example of semantic networks, based on category theory, is O-logs. Here each type is an object, representing a set of things, and each arrow is a morphism, representing a function. Commutative diagrams also are prescribed to constrain the semantics. Software tools. There are also elaborate types of semantic networks connected with corresponding sets of software tools used for lexical knowledge engineering, like the Semantic Network Processing System of Stuart C. Shapiro or the multi-net paradigm of Hermann Hellberg, especially suited for the semantic representation of natural language expressions and used in several NLP applications. Semantic networks are used in specialized information retrieval tasks, such as plagiarism detection. They provide information on hierarchical relations in order to employ semantic compression to reduce language diversity and enable the system to match word meanings independently from sets of words used.